Welcome. Let's start with some vital context. Do you listen to music on your smartphone? Do you keep a list of contacts on your phone? Have you ever seen a leaderboard during a competition? If your answer is yes to any of these questions, then it's almost certain that you've used arrays and you didn't even know it. Shocked face. Arrays are very powerful data structures that store lists of elements. To understand how they work, it's very helpful to visualize your computer's memory as a grid, just like the image above. Each piece of information is stored in one of those small elements, squares, that make the grid. In simple terms, an array is basically a list or sequence of data. Conceptually, an array is best thought of as a collection of items that are related in some way. For example, an array storing numbers that represent the value of the cards within your hand while playing poker. Their elements are next to each other in memory. If you need to access more than one of them, the process is extremely optimized because your computer already knows where the value is located. Awesome, right? Let's learn how this works behind the scenes. Arrays are classified as homogeneous data structures because they store elements of the same type. They can store numbers, strings, Boolean values, true and false, characters, objects, and so on. But once you define the type of values that your array will store, all its elements must be of that same type. You can't mix different types of data. The amazing power of arrays comes from their efficiency to access values. All credit goes to its grid-like structure to achieve this. When you create an array, you assign it to a variable. Define the type of elements that it will store. Define its size, the maximum number of elements. Note: the name that you assign to this variable is very important because you will use it later in your code to access values and to modify the array. How can you tell the computer which particular value you would like to access? This is where indices come in. You use what it's called an index to access a value in an array. This is a number that refers to the location where the value is stored. As you can see in the image above, the first element in the array is referred to using index 0. As you move further to the right, the index increases by 1 for each space in memory. The general syntax to access an element is array variable index. For example, if your array is stored in the variable myArray and you want to access the first element, at index 0, you would use myArray 0. Now that you know how to access values, let's see how arrays are stored in your computer's memory. When you define the size of the array, all of that space in memory is reserved from that moment on for future values that you may want to insert. Note: if you do not fill the array with values, that space will be kept reserved and empty until you do. Let's say that you define an array of size 5 but only insert one value. All that remaining space will be empty and reserved in memory, waiting for future assignments. This is key because arrays are extremely efficient in accessing values because all the elements are stored in contiguous spaces in memory. This way, the computer knows exactly where to look to find the information you requested. Arrays are recommended in situations when you know beforehand how many elements you are going to store. Hey DSA learner! Now that you know what arrays are and when they are used, how they store elements. In this section, we will dive into their operations like insertion and removal. Let's say that we have an array of size 6 and there's still an empty space. We want to insert an element e at the beginning of the array, index 0, but this place is already taken by the element A. What should we do? To insert into arrays, we move all the elements located to the right of the insertion site, one index to the right. Element A will now be at index 1, element B will be at index 2, and so on. Make sure you create a variable to keep track of the last index that contains elements. In the diagram above, the array is filled up to index 4 before the insertion. This way, you can determine if the array is full and what index you should use to insert an element at the end. After doing this, our element is successfully inserted. What do you think will happen if the array is full and you try to insert an element? In this case, you need to create a new, larger array and manually copy all the elements into this new array. This operation is very expensive, time-wise. Imagine what would happen if you had an array with millions of elements. That could take a very long time to complete. Now let's say that you want to delete an element from the array. To maintain the efficiency of random access, the elements must be stored in contiguous spaces of memory. You can't just delete the element and leave that space empty. You should move the elements that come after the element that you want to delete one index to the left. And finally, you have this resulting array. As you can see, B has been successfully deleted. Deletion is very efficient when you remove the last element. Since you need to create a variable to keep track of the last index that contains elements, in the image above, index 3, you can directly remove that element using the index. You have three options to find an element in an array. If you know where it's located, use the index. If you don't know where it's located and your data is sorted, you can use algorithms to optimize your search, such as binary search. If you don't know where it's located and your data is not sorted, you will need to search through every element in the array and check if the current element is the element you are looking for. Let's have a look at the sequence of images below.